Hello, this is Chuck Ridgway, Automation Technology Manager at Horner. Thanks for joining us for another Tuesday live stream. Well, I'm recording my video on the road this week because we're exhibiting at a couple of tech expos put on by our Midwest distributor, Logic Incorporated. Yesterday, we had a great event in St. Louis. We had a lot of fun talking to new customers, catching up with some existing customers, and showing off some new products we'll be releasing over the summer. Today, I'm here in Kansas City, Missouri, and we just got done setting up for tomorrow's expo. I'm especially excited to be here in Kansas City because the expo is being held at Kansas City Union Station, one of the truly historic train stations in the United States. And if you know me, you know I love trains. A couple of years ago, as a matter of fact, I had a chance to take Amtrak to Union Station here in Kansas City as I attended the very first NFL game of the season as my beloved Detroit Lions took on the Kansas City Chiefs. And the Lions beat the Chiefs. What a great experience. Of course, the Chiefs got their revenge later in the season when they won the Super Bowl and the Lions fell short. Well, enough about Kansas City, even though I'm really excited to be here. Let's get into today's topic.
Today's topic is Cscape 10 UDFB Mania, 30 free functions. What's that all about? Well, over the past 2 or 3 years, we've really created a lot of user-defined function blocks, but they're kind of spread out over several different videos, over a couple of years of elapsed time, and we thought it would be a great idea to have a video where we just summarized all the different user-defined function blocks that are available for you to use. Again, all in one video, so you could quickly and easily find the ones that you might want to use on your next project. So what are user-defined function blocks? Well, user-defined function blocks are one of the power features of variable-based logic languages, and really one of the primary reasons we spend so much time on those languages on this channel. UDFBs allow you to take sections of your logic and transform it into a reusable function block with inputs and outputs, just like a regular function block in Cscape. And then once you've created a UDFB, you can use it multiple times in your project. You can then also export it, and in the future, you can import it into a new project and use it multiple times in that project as well. Not only can you create your own UDFBs, you can also import UDFBs that others create, including the ones that we've created here at Horner Automation. That's really what today is all about. Now, before you can use UDFBs, you have to at least be using Cscape 9.9 or Cscape 10. And if you're not using Cscape 10 yet, it's about time you switched because it's been really solid. It's been out many months now. We're even up to Cscape 10.1. Customers have given us great feedback. And even though it's very smart to be cautious, I can assure you that Cscape 10 has been really solid. All of the UDFBs we're going to talk about today were written for variable-based advanced ladder. Sometime in the near future, we'll have another session where we'll talk about the UDFBs we've created for IEC. But today, we're talking about the ones we've done for variable-based advanced ladder. Here's a summary page that tells you in one location all the different categories of UDFBs we've done here on this channel, as well as what some of the individual functions are within that category. So you can see we've got quite a list here. Now, the first several operate on arrays. Okay, so array type variables, and of course array type variables are only available with variable-based advanced ladder and IEC. They're not available in register-based languages. We're also going to show you and talk about a drum sequencer user-defined function block. We're going to show you how you can expand your string handling capability if you've got, ASCII type applications that you need to deal with. We'll talk about what some of those are. We'll talk about something that's called a masked move, which you may not be familiar with, but it can be really useful. And then we have some UDFBs for calculating tank volume and some really interesting ones for doing time math. So let's go ahead and kind of go through these with a little bit of detail. The original videos for each of these UDFBs has all the detail you could ever need. So we're going to reference those videos and allow you to go look those up if you're looking for additional details. All right, here we go. Okay, let's start with array math. So what is array math? Well, really, array math are user-defined function blocks that are designed to perform math and statistical operations on an array or a list of data values. That's really what it's all about, okay? And we'll start with median. What is median? Well, median is the middle value in a list of values, either in ascending or descending order. Okay, so this user-defined function block will report back the middle value or the median. There's the sum array math function. That one's pretty obvious. It goes through the entire array of values and adds all those values together and provides you with the sum. Next, we have the average of values. It goes through the entire list of values and provides you with the average. Then you have min and max value UDFBs. So they'll go through the entire list, they'll find the minimum value, and of course the max function will find the maximum value. Those can be very useful for a lot of different applications. And then finally, we have standard deviation. So it will go through that entire list and do the standard deviation calculation and present that data back to you. So again, another highly useful statistical function that operates on an array of data values. Now, if you need more information, which you may, you can look up this particular video either on our website or you can even just Google the title and I'm sure you'll find it. But there's the thumbnail for that particular video, and in the lower left, you can see the YouTube link for going directly to that video. All right, the next category also works on array type data, and those are data-find UDFBs. So what do those do? Well, effectively, they also work on an array, and what they do is they search that array for a specific value. Okay, so what would these be useful for? Well, certainly they can be useful for ASCII type applications. Maybe you've got a barcode that you've scanned and you're looking for a specific character, so you can use the byte find because characters are expressed in bytes. Or maybe your OCS is operating in a test environment and you've performed a test and you've captured the data from the test, maybe a series of analog values or something, and you want to look for a specific value within those test results. Maybe you're looking for 0. Did we ever have a 0 result in any of the tests? That sort of thing. If you're looking for the video, there it is. There's the thumbnail, there's the title, and there is the link. Next, we have data sort UDFBs. So what these UDFBs do is they'll take an array of data and they'll sort those either in ascending or descending order. And we have user-defined function blocks for sort up and sort down. And we have ones that operate on integers, double integers, and real values. So these are data sort UDFBs. And they use a technique called a bubble sort. And if you want to learn more about what bubble sorts are all about, you can go to the specific video for these data sort UDFBs. Now, there are plenty of applications where these are valuable. Again, we'll go back to the machine test environment where you may be performing a test a number of times and capturing the results, and you might want to sort the results in ascending or descending order. So that's one possibility that I can mention here. But there are plenty of applications where these can be really useful. Okay, so here's an example data sort UDFB on the screen with the inputs on the left, including the input array that you can see there, and then the results on the right, the outputs of the UDFB. All right, here is the title and the thumbnail as well as the link. All right, next we have string handling UDFBs. Now, ladder logic is not the greatest language for dealing with strings. Structured text, as an example, is much better. However, there's plenty of programmers that just prefer ladder. So what we've done is we've added a bunch of UDFBs that replicate some of the string functions that are available in structured text. So that can be really valuable for those dedicated ladder programmers out there. And there's lots of applications today that still utilize strings. Barcode applications, reading and writing RFID tags, maybe card stripe type readers, maybe receipt printing, maybe satellite communications. There's all kinds of applications that still utilize strings in 2025 and beyond. All right, so here's the particular UDFBs that we've got available. And the first few, what they are doing is they're allowing you to extract a portion of an existing string to create a new string. Now, the first one we've got here is called left string. So it's going to extract characters from the left side or the start of an existing string to create a new one. Next, we have midstring, which allows you to take characters out of the middle of an existing string to create a new one. And then finally, we have right string, which allows you to take characters extracted from the right side or the end of a string to create a new one. Next, we have concatenate. That allows you to take two existing strings and create one longer one that is the combination of the other two strings. So that can be also very useful from time to time, especially if you're building a specific series of characters for a special purpose. Certainly, satellite type communications is an example where you have a specific series of characters that you need to add together to create a specific string. And for building strings, concatenate can be really useful. Here's find character. With find character, which is very similar to the find byte function we've talked about earlier, but with find character, you can find a specific character in a string. Where is the carriage return in this string that I just grabbed by scanning a barcode? Okay, because maybe that carriage return kind of signals the start of a specific data field, or maybe it signals the end of the string, which can be a variable length. So all of those sorts of things, the find character can be really useful. And then here is the thumbnail, the title, and the link for string handling UDFBs. Okay, next we're going to talk about drum sequencers. This is one of the more complicated UDFBs that we've created. So what is a drum sequencer? Well, really traditionally, a drum sequencer is an electromechanical device that is very useful in controlling applications that perform a series of steps or stages in a repetitive order. Okay, so a good example for that, or the traditional example for a drum sequencer type control, would be a washing machine or maybe a dishwasher, where you've got a fill cycle and you've got a rinse cycle and you've got a wash cycle. And these particular steps have different outputs on during these steps, and the steps can last for a certain duration of time, or they could be waiting for a specific sensor to trip or something like that before the specific step or sequence is complete. So graphically, this is kind of what a drum sequencer traditionally looks like, where you have a series of steps, okay, and in each step you have one or more outputs that can be on, kind of represented by those pegs, and then a motor is turning your drum at a continuous speed to kind of represent time, if you will, okay, and this is really what people think about when they think about a drum sequencer. Now you're thinking, this looks pretty old-fashioned, why would I ever want to use that? Well, if you think about it, there are a lot of applications that have a series of sequential steps or stages where different outputs can be on in different stages, and either a specific input will cause you to move from one stage to the next, or maybe a specific amount of time will cause you to move from one stage to the next, or maybe time and an input changing will cause you to move from one stage to the next. So these can be really useful ways of controlling sequential type machines. So that's why we created this drum sequencer user-defined function block. And again, I'm not going to go into much detail here because we have a very detailed video that will give you all you need to know about the drum sequencer. But our drum sequencer is quite capable. It can handle up to 16 steps. It can control up to 16 outputs. It can advance from step to step based on time. It can advance from step to step based on an event, like an input changing state, for instance. Or it could be both have to happen before you move from one step to the next. So very capable UDFB there, and here is the title and the thumbnail and the link to this video. Okay, next we have something called a masked move. What is a masked move? Well, a masked move is a move function, a special move function. Remember, move functions are where we move data from one variable into another variable. That's a move type instruction. But a masked move is a move instruction where we only move part of the data from a source variable into a destination variable, not the entire thing. And you'll find applications where they're cramming every single piece of data they can into a very small number of data bytes. Those are the sort of applications that really can utilize packing and parsing, and they can really utilize masked move as one of the tools to pack and parse the data. So networks like CanOpen and J1939, where they're sending a ton of data in a small amount of space to be super efficient, satellite and cellular communication examples, sometimes even in Modbus communications, and then in barcode and RFID type applications as well. So again, anytime you need to pack a lot of data in a small amount of space very efficiently, you want to utilize every single bit, the mass move is really useful for that. So as you can see here with a mass move, you're going to specify the source variable that you're going to move. You're going to specify the destination variable that you're moving the data to, and then you're going to specify how many bits or which bits of the source variable are actually going to be moved, and then the result is placed in the output. Okay, and then there's this clever thumbnail that Marcy created. This is one of my favorites that she's created over the years. That I can't tell whether that robber is a robber or a ninja robber. So great job on that, Marcy. That's our massed move link right there. Okay, next we have tank volume UDFB. So these are user-defined function blocks that were customer requested that allow you to calculate volume based on the level of a tank with either a known geometric shape or where the manufacturer has provided a data table of level versus volume for that particular tank. So we've got those two different categories that we can handle. Here is a kind of a graphical look at the different tank geometries that these support, as well as in that last column there, a graphical representation of a tank volume table that would be provided by the manufacturer. Okay, and here are the thumbnails from the videos where we've covered these, and the one for tank volume from a data table is one from just last week. All right, finally, our last category is time math user-defined function blocks. These are incredibly useful, and they seem like they should be really simple to do without having a function block, but the reality is the function blocks are real time savers out there. Okay, so what are time math UDFBs? Well, basically, they are function blocks that perform math type operations, but where the operands are hours, minutes, seconds, or month, day, year, or some combination of the above. Okay, what types of applications would those be useful for? Well, applications where you're answering the question, what is the projected service date for this machine? How many days has it been since the machine was maintained? Maybe you want to calculate that and show it on the screen. How long has the machine been powered down? Sometimes when a machine has been powered down just for a brief amount of time, you want to react as if the power outage never occurred and just continue on with the process. Other times, if it's been down for longer, you may want to react completely differently, maybe even starting the process completely over. So these are really valuable user-defined function blocks. Okay, so let's go through those. We've got an elapsed time user-defined function block where we have a start time and an end time that are specified, and then the result of that are the number of days, hours, minutes, and seconds of elapsed time between start and end. And you can see that both start time and end time are in the form of an array that's in seconds, minutes, hours, dates, months, year. And if you sat down and thought about how you would do this logic and really thought about it, you'd realize that it's a fair amount of work. So take advantage of this function block. We've also got a couple of add functions, one for adding days to a start time, another for adding hours to a start time. And in both cases, they give you the result in terms of the time and date when the end time will occur. So these are also very useful. And then we have our power off time UDFB. Again, this is the one where you may want to react completely differently with your control algorithm depending on how long a machine has been powered down. Okay, and then here's the thumbnail as well as the link for this particular UDFB category. So hopefully you found today's video useful. The ability to see all the different UDFBs we've created over the past several years in a single video. And remember, you can always go back to the original videos that we referenced for demonstrations and all the additional details you could possibly need.
Well, that does it for today's topic. Next week, we're going to show you how you can integrate a keyboard and a mouse with Canvas OCS. We'll show you when to use it, why to use it, and how to use it. We'll go over that with you next week. If you haven't subscribed to our channel yet, don't hesitate to do so. It doesn't cost anything. And if you choose notifications when you subscribe, you'll be notified every time we go live or every time we post a new video. So until next week, let's all get out there and do some good.